So on page 126, those problems 1 through 6, they say for each value of the real number s, find s of s, cosine of s, tangent of s. The thing that they haven't specified is that s is the arc length on a unit circle. Because if it wasn't that, then the sine of the arc length is not going to be the sine of the septal angle. So those problems are unit circle problems. Okay, on page 126. So they're saying s equals pi. And I would specify where r equals 1. Then what we have on number 2, this is number 2, then you're going to do the sine of pi. And the sine of pi is what? Remember, pi is 90 degrees equivalent. So 180, excuse me, 180 degrees is equivalent. So if we're so this particular one, what we have is that's pi. Or if it's on the unit circle, it's that arc length is what we have. The arc length is pi. So what is the sine of pi? No, sine. Pi is equal to 180 degrees, but they're asking what's the sine of pi, or equivalently, what's the sine of 180? Well, if you recall, you start out with a sine down here. When you're down here, the sine is 0 at this point. When you get up here, the sine is 1. And then what I'm doing is going cosine, sine. So this is 0, this is 1 on the unit circle. We're 1 unit out, that point is 1, 0. When you get up here to pi over 2, that right there, then what you have is the cosine is 0 and the sine is 1 on the unit circle. I ordered pairs. And then when you get back down here on the unit circle, it's the ordered pair is minus 1, 0. And it's always cosine sine. So sine is 0. Now, I'll just go around on the unit circle. If we call the unit circle is 1 unit out, draw the thing. Let's just go out so we get wide enough. I'll go 4 units out. And what I'm calling this is the distance from here up here. That radius is 1 unit. Now, this particular point right here, that particular point right there has an ordered pair of what? X is 1, Y is 0. Now, if you go clear back to the beginning of what we talked about, the sine of an angle is equal to Y over R, right? Isn't that right? Way back. Well, Y is 0 in this case, and R is 1, right? So technically, on a unit circle, these ordered pairs are the value of the cosine of either the central angle or the arc length sine. So whatever those ordered pairs are, it's going to be cosine sine. So when you get up here at this point on the unit circle, once again it's 1 unit long, what is the ordered pair? 0, 1. So on a unit circle, this arc length is equal to this central angle. And when you do the cosine of the arc length, it's 0. When you do the sine of the arc length, it's 1. And this arc length from here to here is pi over 2. The central angle, when measured in radians, is pi over 2. And measured in degrees, it's 90 degrees, right? Correct. Then when you go down here to that point right there, the ordered pair here is what? -1 and 0. And so cosine is -1, sine is 0. And the arc length, if you say of that point, is pi. The central angle is pi. And in radians, and the central angle in degrees is 180 degrees. And on a unit circle, the length of the arc is the same as the measure of the central angle in radians. They're the same. So then they can say the cosine of the central angle and the sine of the central angle is the same thing as the cosine of the arc length S, sine of the arc length S on a unit circle. That's the unit circles. That's what we're dealing with now in trig functions. And then there are other important arc lengths or central angles. There's this one, which is pi over 6. This arc length is pi over 6. This central angle is pi over 6. Or in degrees, the central angle is 30. It's 30. The next arc length that you're going to deal with that is in increments of 30 is pi over 3. That arc length here is pi over 3. Central angle is pi over 3. The degrees of the central angle at pi over 3 is 60. And then the other unique one that we always work with is pi over 4. So that arc length is pi over 4 on a unit circle. That's what that is. Central angle is pi over 4, and the central angle in degrees is 45. Now, in terms of ordered pairs, that point has an ordered pair of, well, it's going to be, what is the cosine of 30 degrees? It's going to be the same as the cosine of pi over 6, which is on a unit circle, pi over 6 on arc length. What is that? Square root of 3 over 2. And what's the sine? 1/2, right? So this from here if you drop it perpendicular down to this axis, this length from here to here is the square root of 3 over 2, and that's 1/2. And it all relates back to a point in a plane where sine is defined as y over r and cosine is, but the r is 1 here. And then the next important point is this one where the cosine is the square root of 2 over 2 and the sine is the square root of 2 over 2. That's an arc length of pi over 4 on the unit circle, a central angle of pi over 4, or 45 degrees. And then this point on the unit circle is going to be what? It's going to be the same as the cosine of 60. What's the cosine of 60? 1/2. And the sine of 60 is square root of 3 over 2. Now you notice what happens. The cosine starts at 1, goes to the square root of 3 over 2, square root of 2 over 2, 1/2, 0. Then when it goes back here, then you get to this point right here in terms of arc length is going to be what? 2 pi over 3, right? See, it's pi over 3, 2 pi over 3, 3 pi over 3, right? So this is 2 pi over 3. That's the arc length. It has a central angle of radians 2 pi over 3, which is the same in degrees of the central angle of what? 60, 120, right? So whatever your sine cosine is for 120 degrees, it's going to be that. But you see what happens is here our cosine is 0 and it goes to what? Negative 1/2, right? And now the sine goes to the same as this, because the height is the same as that. Square root of 3 over 2. And then when you get back here, which is, this is pi over 4, 2 pi over 4, 3 pi over 4, right? When the cosine is negative square root of 2 over 2, square root of 2 over 2 for sine. When you get here, what do you have? This is in 6. This is pi over 6. This is 6 pi over 6. So this is 5 pi over 6. And now the cosine is going to be what? Negative square root of 3 over 2, and the sine is 1/2. Then when you get down here, cosine's a -1 and the sine is 0. And then you're just going to go down here. Notice that those numbers, those ordered pairs, come down in terms of sine as you go from pi over 4 to pi, starting out at 1 and going all the way through the same numbers. So you just have to know what quadrant it is, what are the signs of the x and y coordinates in that quadrant, and then those values, and they just keep repeating. Now you notice that all of the problems, 1 through 6, are, what do we call them? It's either going to be pi over 2, pi, 3 pi over 2, or 2 pi, right? That's what every one of those things are. Or else it's going to be a negative pi, or a negative pi over 2. Those are quadrantal, right? And they're going to all have what? They're either going to be 1, 0, 0, 1, 0 minus, or -1, 0, or -1, 0 minus 1 down here. So like on number 4, where are you at? Where are we at? 3 pi, 1 pi, 2 pi, 3 pi, right there, right? So what is the sign at right here? 0. What's the cosine? And then the tangent is going to be 0 sine over cosine, right? 0 over minus 1, 0. So those are all just quadrantal angles that they're showing. Where the, and remember that they're talking about arc length. They're not talking central angles. 7 through 21, the instructions are, find the exact circular function value for each of the following. And they're talking this same thing. They're talking arc lengths, because circular function is arc length stuff. So 8 is going to be the cosine of 5 pi over 3. So back here on this unit circle, where's 5 pi over 3? Well, where's that? It's down here in this quadrant down here, isn't it? And it's this angle right down here. I mean, it's the arc length is this one that's right here. This one right here. That is 5 pi over 3. Because 6 pi over 3 would be 2 pi right there, right? So this is 5 pi over 3. So now what's the ordered pair at 5 pi over 3 on the unit circle? What? Okay, the cosine is going to be positive 1/2, and the sine is going to be a negative square root of 3 over 2. So what are they asking us for? The cosine of pi over 3. So which one is it? 5 pi. It's the 1/2, isn't it? Because the ordered pair is always cosine sine. Look at 12. It's saying the cotangent this was 1/2. The cotangent of 5 pi over 6. So let's go back and look. Where's 5 pi over 6? It's right there, right? 5 pi over 6 is right there. It's that arc length. Now what is the cotangent? The tangent is what? Sine over cosine. So the cotangent is cosine over sine, right? So what we have for cotangent it's the cosine 5 pi over 6 over sine 5 pi over 6. The cosine is a minus the square root of 3 over 2, right? And the sine is 1/2. So you invert and multiply. This is a negative square root of 3. Now the thing that you got to use, and I've drawn it up here, is that unit circle. Back on page 119, they're showing you those. And remember, that's a unit circle. That isn't any circle of any radius. That's a circle of a specific radius 1. Say it again. Yeah, what we'll do is I don't know, but I have handouts. Did that handout? Did I give you a handout for that in this chapter? No, I have a handout where I make copies of this, but you have to know it. But I will look for that handout. I think it's probably in the test, copy of the test. But you can use that. You can use that on the exam. But this unit circle is going to be used so much that it needs to be something that the only reason that you need to look at the unit circle is to verify that you've got the right number. You should have basically know the right number, because it's all those things are, and really all you got to learn, all you have to learn is the ordered pairs of X and Y, and those numbers just repeat. You just got to know which quadrant you're in, and then know that it's cosine sine, and then you can do all of them, right, by identities. You know cosine sine, you can do tangent, because tangent is what? Sine over cosine. You can do secant, because that's 1 over cosine. You can do cosecant, because that's 1 over sine. You can go cotangent, because that is cosine over sine. So if you know the unit circle and you know the values there, and then every angle, when they ask for exact, they're going to be giving you these values or multiples of them. 360-degree multiples. The pi over 6, pi over 4, pi over 3, pi, and so on. If they want you to use the calculator, then it'll be given to you in probably decimal equivalents, and because you won't have this exact values to solve for. But in order to do the inverse functions, we've got to learn some more about some things to really use the calculator adequately. So let's just look at 20. 20 says cosecant of 13 pi over 3. Now, what you got to do is try to figure out what the coterminal angle is for this. And that means that what you have to do you've got to subtract successive 2 pi's out of there. So that would be successive 6 pi's over 3, right? 2 pi's would be 6 pi over 3, correct? So you can subtract 1 6 pi over 3, and you would get then 7 pi over 3. If you subtract 2 6 pi's over 3, you would have 12 pi's over 3, which would give you cosecant of pi over 3. That arc length is coterminal with the arc of pi over 3, because I've subtracted 2 pi's out until I get, and 2 pi's are 6 pi over 3, right? 2 into 6 is 3, 3 into 6 is 2. So if I take 6 pi's over 3 out, in other words, keep subtracting 6 from this numerator until I get something between 0 and 6, and you see I can subtract the 6 out twice. So that means that I have a pi over 3 left. Everyone understand what I did? I'm subtracting out 2 pi, right? 2 pi is 1 time around. Isn't that right? 1 time around the circumference. That's equivalent to 6 pi over 3, right? So I'm going to subtract successive 6 pi's over 3 out of this. So I'm taking 6 away from 13. Once I'm not in one rotation, I have to subtract 12 out, and then I got 1 left. That means that I'm coterminal with this. Is that, now I'm, okay. So now if you look at your unit circle, I'm coterminal with this arc length. 13 pi over 3 has gone around there twice, come back right up here. And I've subtracted 2 rotations out to find out that's where I'm at. That's my coterminal angle. That has a cosine of 1/2 and the sine of square root of 3 over 2. So the cosecant is actually what? 1 over sine. And the sine at pi over 3 is what? Square root of 3 over 2. Is that right? You can look back in your book and see it. So that's 2 over square root of 3. Right? Lucas, where did I lose you?
At the end, it needs to be 2, 3.
Yeah. This I have to rationalize, but I was just saying, are you with me to there?
Yeah.
Okay. So then I rationalize the denominator, and it's 2 square root of 3 over 3, and that's my answer. Does that make sense, James?
I don't understand what's going on. I'm helpful that I can reproduce it.
Yeah.
Again, I
Yeah.
can let it sink in.
Yeah. Well, what you have to do is do some of those problems like right beside it, and then figure out where. But you're going to have to find the coterminal arc length with that arc length in 1 rotation. And remember that, if your denominator is 6, then you're going to take successive 12s out, right? Because 2 times 6 is 12. So it'd be 12 over 6 is 2. And that would be a 1-time rotation. And, your denominator is either going to be 3, 2, 3, or 6 for exact measurements. Because we have pi over 3, pi over 2, pi over 4. So you'd have 8 too. Because you have first one's pi over 6, then it goes pi over 4, then it goes pi over 3, and then pi over 2. So you would have to have, if your denominator is the 6, then you're going to take successive 12s out. If the denominator is 4, you take successive 8s out. If it's 3, it's successive 6. If it's 2, it's successive 4s until you get in the 1 rotation.
Last chapter, we were striking 360.
Yeah, 3. That's the same thing, except radians. You're going to subtract 2 pi radians because one time around the circumference is 2 pi. Yeah. Okay. And then you got like 18. You see, then you're going negative direction. So then you got to be sure that. Let's just, for example, look at 18 where they say sine of a negative 5 pi over 6. Now, a negative 5 pi over 6 is going to put you where? It's going to put you right there, isn't it? And then you have to, it's going to put you right here. This is negative 5 pi over 6, which is the same as 7 pi over 6 coming this way around. So just make sure that you know where you're at by Does that make sense? Then you just say the ordered pair here, cosine is gonna be what? Well, it's gonna have these numbers, but then what are, both of them are gonna be negative, aren't they? And now you're ready to do whatever trig function they're asking for. And they're asking for sine at that negative point. So that's equal to a negative 1/2. Okay, Chris Sharp, do you have it? Okay.
The only question I had was, on that last problem, where did you get the 2 pi from? Is that just equal to?
2 pi is, you mean this little thing that I put right here?
Yep, exactly. Okay.
Well, what it is that you have to, see when this is 13 pi over 6, that's not in one rotation.
So,
It's a multiple rotation. So what you have to do is you have to figure out what am I going to subtract from 13 in order to subtract rotations out. When the denominator is 3, I have to subtract 6 out, right? Because 6 over 3 is 2 pi.
oh,
So I'm subtracting out 2 pi, which is technically subtracting 6 out of this 13.
okay.
So I do it. Now, if the denominator was something else than that, and the something else is what are the choices we have. If you look at your exact values, you can have a pi over 6, right? You can have something over 6, right? Well, if it's 6, then this 2 pi is equivalent in terms of 6 in the denominator of 12 pi over 6, right? Now, in terms of 4 in the denominator, that 2 pi is equivalent to what? 8. 8 pi over 4, right? So see, all of these are 2 pi. So when you're trying to subtract out, depends on what your denominator is. And your denominator is either going to be, it's either going to be 6 or 4 or 3, or else it's going to be a 2, right? So what would you have if the denominator were 2 to get 2 pi? 4. So then depending upon what this is, what you would subtract out of here would depend upon that. If that were a 6, then you'd take 12s out, right? If this is 3, then you take 6s out. If that denominator is 4, then you take 8s out.
So that's just how many times it goes into the numerator?
You're just subtracting it out until you get something between, like in the case of when you're doing this one, something between 0 and 6. Then you know you're in the first rotation. And that's coterminal. Because what you want to do is you want to, this unit circle is all you got, and that's one rotation.
That's my question.
I know, I was just waiting, does that make sense?
Yeah, it makes sense now.
Okay. And all this is telling you what you subtract. And it all depends on the denominator. All right, well, I'm going to quit there because I'm going to give you a quiz. We're not going too darn fast because some of you get it, but some of you haven't had it. And this is pretty important stuff because we're going to do sinusoidal curves, and it's going to come from the understanding of this material right here. So you got to know what's y doing as you go around. And you have to understand the relationship between the arc length, because what we're going to do is we're going to take that arc length and we're going to lay it out horizontally. And then we're going to measure the y values, what they look like, and how they plot out to get the sinusoidal curve or the cosine curve or the tangent curve. So you gotta understand this unit circle concept. And once you get it down, and once you understand it, then it's gonna be easy. But if you mess this up, then the sinusoidal curves will be something you'll be learning totally independent of everything else. And these are all related. You know, I hope that you see that the point plots in a quadrant is related to this in the way we evaluate it. So is right triangle trait, and just all of it has a relationship.